Explicit and recursive processes. An explicit sequence will be given as a generalized function in terms of n, and it will be written as a sub n equals f of n. Let's do some examples to understand how to create these sentences. Find an explicit function for the sequence 20, 24, 28, 32, 36. So the first thing you should notice is we add 4. And we start at 20. Okay, so if that's the case, well, we know somehow we should probably have a 20 in there. And then what do we do with that 20? Well, we go 20 plus 4, and then we go with that answer plus 4, and then that answer plus 4. So we have to just use an n. Keep in mind that n is just the number that it is. So my n would be 1 for the 20, and 2 for the 24, 3 for the 28, 4 for the 32, 5 for the 36, and so on. So each number is the next n in line. So somehow I have to use a 1 and an n to get 20 for my first number. So if I go 20 plus, well, n minus 1, because n minus 1 would be 1 minus 1, which is 0. 0 plus 20 is 20, so I get the right answer. Let's see if I put 2 in, if that makes sense. So 2 minus 1 is 1. 1 plus 20 is 21, so that doesn't work. So somehow I need to get it to add 4 instead of just adding 1 there, because this will add 1. So what if I multiply this times 4? So now let's try that. If I put in 2, 2 minus 1 is 1, 1 times 4 is 4, 4 plus 20 is 24. Well, that works. Put in 3. 3 minus 1 is 2, 2 times 4 is 8, 8 plus 20 is 28. So I think we found our sequence. Now we just simplify the sequence, and we have 20 plus 4n minus 4, if we distribute there. And that would be 16 plus 4n. And our final answer, a sub n equals 4n plus 16. And there's your final sequence. The next example here, 1, 4, 9, 16, 25. This one seems fairly straightforward to me. It looks to me like it's just a number squared. Because 1 squared is 1, 2 squared is 4, 3 squared is 9. So if we recall that our n's, this is my first n, second n, 3, 4, and 5. So I need to do something with a 1 and an n to get 1. Well, what if, like I just said, I go n squared? 1 squared is 1. 2 squared is 4. So it seems to be like I'm just going to go n squared. So my final equation is just going to be a sub n equals n squared. That one was a little bit easier. Recursive sequences are a little bit different. They will be given terms of one or more terms to begin with. So there's going to be multiple things to look at, but it will kind of help you start your sequence. So in this case, we have a sub 1 equals 3 and a sub k equals 2, a sub k minus 1 plus 1, and that's for any k that's bigger than 1, so 2, 3, 4, and so on. So if I want to write the first 5 terms, I already have the first term. A sub 1 is equal to 3. I already know that. So my a sub 2 is going to be equal to a sub k minus 1. Well, k minus 1, k is the subscript, so k minus 1, 2 minus 1 would be a sub 2 minus 1 would be 1. So that's equal to 2a sub 1 plus 1, which looks like 2 times 3 plus 1. So that is equal to 2 times 3, which is 6, plus 1, which is 7. So my a sub 2 term is 7. A sub 3, same process. 2a to the 3 minus 1 plus 1 equals 2 to the a sub 2 plus 1 equals 2 times 7 plus 1. So 2 times 7 is 14 plus 1 is 15. A sub 4. 2 to the a sub 4 minus 1 plus 1 equals 2. A sub 3 plus 1 equals 2 times 15 plus 1 equals 2 times 15 is 30. 30 plus 1 is 31. And finally, a sub 5, last one that we need to find, 2a sub 5 minus 1 plus 1 equals 2a sub 4 plus 1 equals 2 times 31 plus 1. 2 times 31 is 62. 62 plus 1 is 63. So the first 5 terms of my sequence is 3, 7, 15, 31, and 63. For this next one, again, we have to write the first 5 terms of the sequence. So the first thing I'm going to do is write down what I know. I know a sub 0 is equal to 1. Well, I don't really need a sub 0. I need a sub 1, 2, 3, 4, and 5. But I have the information, so I'll write it down. A sub 1 is 1. A sub k is equal to a sub k minus 2 plus a sub k minus 1. So it looks to me like we're just going to add the 2 previous terms, because k minus 2 would be 2 minus 2, which is 0, so I'd be a sub 0. And then k minus 1 would just be the term right before it. A sub 2 equals a sub 2 minus 2 plus a sub 2 minus 1, which would be a sub 0 plus a sub 1. So that would be equal to 1 plus 1, which obviously that is 2. All right, a sub 3 is equal to a sub 3 minus 2 is 1 plus a sub 3 minus 1 is 2. So a sub 1 was 1 plus a sub 2, which was 2. 1 plus 2 is 3. A sub 4 is equal to a sub 4 minus 2, which is 2, plus a sub 4 minus 1, which is 3. A sub 2 is 2 plus a sub 3, which is 3. So a sub 4 equals 5. And finally, a sub 5 is equal to a sub 5 minus 2, which is a sub 3, plus a sub 5 minus 1, which is a sub 4. So that is equal to 3 plus 5. 3 plus 5 is 8. So the first 5 terms of my sequence are 1, 2, 3, 5, and 8. For these last examples, we want to actually find a recursive formula. Finding the recursive formula is actually easier than finding an explicit formula, because you just write down your a sub 1 term and then figure out how to go from a term to the next term. So just figuring out that you need to add 2 or add 4, like in our first example, is enough to write a recursive formula. You don't have to actually manipulate the numbers anymore. So for this first one, my a sub 1 term is equal to negative 1. And I can say that because my first term right here is negative 1. Remember, these are my n's. So n equals 1, 2, 3, 4, and so on. So my a sub 1 term is 1. And now I want to come up with an a sub k term, just like before. And I can use the previous number. So what do I do to this negative 1 to get 1? Well, if I add 2, I get 1. Make sure that it works for the next one. 1 plus 2 is 3. Plus 2 is 5. Plus 2 is 7. So it looks like just adding 2 to the previous term will work. So all I have to do is write my a sub k is going to be equal to my previous term, which is a sub k minus 1. And then I just add 2. So that is my recursive formula. And the next one here, I have 1, 3, 9, 27, 81. So again, start with your a sub 1 term. A sub 1 is 1. And then I need to do something to get to 3. So I suppose I could add 1. Or sorry, add 2 again. But then when I look 3 to 9, I can't add 2. That would be adding 6. So that doesn't work, so I can't just add. But what else can I do to get from 1 to 3? Well, I could maybe multiply by 3. What if I multiply 3 times 3? I get 9 times 3. I get 27 times 3. I get 81. So it seems like instead I'm just going to multiply by 3. So my a sub k is going to be equal to 3 times my a sub k minus 1. So that would be my final recursive formula. That's it for your notes over explicit and recursive processes. Go through the practice problems. Make sure that you can actually do these types of problems. They're a little bit more difficult, a lot more thinking involved, and trial and error type of things. And then prepare for your quiz over the material.